Our next topic is logistic regression. So now logistic regression is nothing but it is related to your classification algorithm, and here we are trying to understand how this logistic regression actually works. So let me just write. Now in this logistic regression, basically what we are trying to predict, we are trying to predict the log odd. Now if you just check the equation, so here I'm just taking ln p by 1 minus p equal to uh, alpha plus beta 1 x1 plus beta 2 x2. Now this portion is already it is known to you. It is more similar to the simple linear regression, but this part, this y part, is a little bit different. So here what we are, let me just explain what are the terms. P is nothing but the probability of a particular event. Let's say you want to predict whether a particular event it going to fail or it going to or it going to be a success. Let's say later we will be implementing one problem, case problem, that is Bollywood film success prediction. There one was the success or let's say the one positive case, and 0 is the failure of the movie or the negative case. So in that case this P is nothing but the probability of being success of the particular movie. So this P by 1 by P, this term is known as the log odd. Okay, so base of this entire method is nothing but trying to increase the or maximize your log likelihood. And you just remember the concept of the linear regression. It was we try to minimize the least square error. So here we are trying to increase the log likelihood. So now if we just check this thing, so this beta is again your regression coefficient, and definitely x1 and x2 is your predictor or your independent variable. So now if I just dissect or just try to okay, obviously alpha is the intercept. Let me just mark this beta coefficient or regression coefficient. Now in this case, if I just find out what is the expression of P, so definitely P is, or the probability of a success or probability of getting one or positive case is nothing but, so I'm making it more simpler, 1 minus P, and this portion, let us just erase this part so it will be easy to understand, e to the power this term. And if I add 1 both side, then we will get one divided by 1 by minus P, or a simple thing we can do that we just take a plus, first we will add 1 both side and then we just flip it or take the inverse of that. So in that case what I will get, I'm getting 1 minus P, that is equal to 1 by this term e to the power alpha plus beta 1 x1 plus beta 2 x2 plus 1. And if you just try to find out what is the P value, in that case P will come, the P equal to 1 minus this entire term. So the final expression of P is e to the power alpha plus beta 1 x1 plus beta 2 x2 divided by e to the power alpha plus beta 1 x1 plus beta 2 x2 plus 1. So this probability is nothing but the probability of your particular event. Now, so in case of logistic regression, if you just plot this entire expression, then so you will get a curve like this. Okay. So now, if I just observe this curve, so this part is kind of a, if I consider this is 1, this is 0. So definitely in between this entire curve, if I select a particular value, and by the way, this is the probability value. So a particular value, let us say maybe 0.5, if I consider that is 50% probability, beyond this it will be a case of success and below it is failure. So in that particular calculated p value, if you put a bar or threshold, then it can create easily a model where you can find out, okay, if let us say a case where your the probability is 90%, that is a case of success, and if it is let us say 40%, then it is a case of failure. Okay. So hope you understood the basics of logistic regression, how we work it, and based on this this cutoff value, okay, we can easily tune our model or our logistic regression. Most of the cases, the basically the common value is 0.5, basically this threshold value, and you can apply it easily for improving your model. In multiple cases, you can reduce this value, or maybe you can increase this value to suit your particular application. So hope you understood the basic of this logistic regression. Thank you.